But they use 600 gigawatt hours of power every day and need replacing every 15,000 hours, or every 3.5 years. But one company in Hungary has had a light bulb moment, making bulbs that last longer and use less power, saving millions of dollars. How do they do it? Thomas Edison's 1879 US patent for an electric lamp is generally considered to be the birth of electric lighting. His early bulbs worked by heating a filament till it glowed. High-intensity discharge bulbs work differently. They send an electrical charge, or arc, through a mixture of chemicals enclosed in a heat-resistant capsule. The current vaporizes the chemical mix and creates a superhot plasma that emits a bright light. The capsule is then enclosed in a hardened glass bulb. Although they're 8 times more efficient than incandescent filament bulbs, they still cost a city the size of London more than £20 million a year in electricity bills. They're not just expensive to run. The color of sodium lights can cause problems for car drivers. In the orange light, our vision is worse, and drivers can be more stressed and less focused. Tungsram in Budapest, Hungary, is one of the oldest light bulb companies in the world. Here, they're manufacturing the solution, the next generation of streetlights that can address many of these problems. Laszlo Shubian runs the factory.
We are established more than 120 years, so we are producing a lot of lamps. This is a light bulb for street lighting, what we are producing today.
To make a streetlight more efficient, the arc needs to run extremely hot, over 3,000 degrees Celsius, approaching the temperature of the Earth's core. But in older generations of streetlights, the capsule can only withstand temperatures up to 900 degrees Celsius. The answer is to use an ingenious capsule capable of withstanding the more extreme temperatures of the superhot plasma. To make this, aluminium oxide powder, often found in spark plugs and glass, is ideal. It has a melting point of over 2,000 degrees Celsius. Trouble is, in its powdered form, it can't be molded into tube shapes. So it's mixed with binding agents in what looks like a giant kitchen blender. Manager Adam Eges oversees the process.
We are the mixing room. The raw material here we mix together, which is like the cottage cheese. But of course, we cannot eat it.
The cottage cheese-like mixture is transferred to an extruder. Inside this, 40 tons of pressure compacts it into a solid tube. That's then cut to 2.5 centimeter lengths using a diamond cutter for precision. To make them translucent, they use a process called sintering. They heat the pieces to 1,850 degrees Celsius. Ernu Shashhegi is the man who makes sure we see the light. He takes his job very seriously.
Történik meg, és utána egy áttetsző kerámia lesz, és innentől lesznek a fényáteresztése.
After 6 hours, the capsules are translucent and super heat resistant. In an airtight chamber, a tiny nozzle injects mercury and a mixture of compounds made up of other metals and halogens, called metal halides. Once filled, they get the thumbs up. In contact with the electrical arc, this mixture will vaporize, producing a bright white light, in stark contrast to the yellowy-orange glow of old streetlight bulbs. The capsules are sealed in 20-centimeter glass bulbs, and an Edison screw fitting is attached. As well as producing a much whiter light, this new bulb is more efficient and will last a staggering 24,000 hours, reducing costs and making our streets brighter and safer.